why we're doing something important. Part 1. At Toyota, we merged inventory, essentially, with a production line. This is the incoming and the outgoing. Smaller piles of cars out the back door, smaller reservoirs, if any at all, of raw materials coming in through nicely planned logistics, getting just the materials that you need, just when you need them. This is called just-in-time manufacturing. Toyota invented just-in-time manufacturing, and that's a big concept within lean manufacturing altogether. This is stuff that Ford and Chrysler have copied Toyota for the last 50 years. At SCUTTLE, we're developing just-in-time design. This is also a merger of different elements that take place in the processes of developing technology. In this case, developing a design, which in reality, design and manufacturing are not separate. They must operate together. Here's a sort of series of prototype components. If you make a new engine, for example, you have the previous tech that you start with. Previous technology solved 1,000 problems. And the concept built into a prototype doesn't change every part of your technology. It has some new tech. And that requires some engineering. And the engineering is injected to say, all right, disregarding cost, disregarding constraints of manufacturing, we're going to make a fully functioning unit of this concept. It's not a concept anymore. It's working exactly as intended. That's what a prototype is. Same RPM, same fuel pressure, same everything as intended. So engineering is added to make this prototype, and they'll send it to their special shop. They'll outsource whatever they need to make machining done, custom, and add something like D4S, direct injection, and its associated elements. Then you have a prototype. And the next prototype is off tool to go from this single piece prototype to, say, 10 pieces or 100. They say, no, we're going to do more engineering. And we'll get to the same design yet again. Same calibration will be needed. Same sensors are in it, everything else. But the parts will be made on the production tooling. And this engineering, these are different engineers. These are manufacturing engineers. Some of them are within Toyota. Some of them are within the third-party vendors, the tier 2 manufacturers. For example, we had an oil strainer made by Roki Japan, and their engineers have been doing injection plastic for more than 50 years, and they know every bit of how the hot molten plastic will flow into this steel reservoir and form the final product, and when it cools, will it eject itself from the mold, etc., etc. This one actually may be made with non-prototype tooling, not a CNC machine, but a real mold, but it's an aluminum mold. So we're getting as close as possible to something the calibration team could receive, and it will behave exactly like every burr will be close to the burr that, anyway, off tool is the next stage. Engineering goes in. Then you have off process. This is serious. This is, you have final tooling, and you have the final process where, all right, after we design an assembly line, every screw that gets put in, some of the screws will be put in for assembly by the robots, and some screws will be put in by people with air guns, so that the bolt gun used by the man on the assembly line who's tightening down a bolt to spec is taking that spec from the design engineer of way back to the concept. To hold the heads, the aluminum heads on the aluminum block, we're going to need this many foot-pounds of torque, and that will not warp too much. And that design intent has to carry all the way into when we design a production line to, they literally dial the pressure, the air pressure of the tool to achieve a certain torque on that bolt, to achieve a certain tension on the shank of the bolt, to achieve a pressure on the head of the aluminum cylinder block. And that still hasn't been achieved until you have off process. So there's a lot of engineering done here. And just-in-time design it's incredibly challenging, because you need to understand, you need to have designers that understand enough about each of these stages, including the manufacturing process, to be able to design something that merges the requirements and produces this level prototype at the same exact time as this level prototype. The magic we're using to do this is all related to digital design and parametric design, and deeply understanding the manufacturing process and having a manufacturing process that is digital. It's digitally controlled. So when you decide on the torque that's going into the bolt, you already know that torque can be fully controlled digitally, because whichever machine you're using to build your off-process parts is calibrated separately from the design of this prototype. So you trust that this digital manufacturing will take place meeting the parameters you have input from the start and in your design. It's a digital, the CAD model and the design itself, it encompasses the information to have the geometry and the information to have the process. It's all stored digitally. And explaining the ins and outs will take a much longer video. But here we have just-in-time design. There you go.